Okay, this tutorial is going to show you how to compute the correlation matrix for a set of data that contains multiple columns. There is a correlation function in Excel that you can give it 2 columns of data and it'll compute a correlation coefficient. But what we're going to do is we're going to have a whole bunch of columns, and we're going to have a whole bunch of different combinations of pairs of variables that we would want to look at and get the correlation coefficient. So what I'm going to do is, again, go to my Data tab and go to Data Analysis. And the choice that I'm going to pick this time is called Correlation. And I want to give it an input range. Now, I want to find the correlation coefficient between price and the number of bedrooms, and price and the square feet and the number of bathrooms and all of these things. And I've got a lot of data in there it probably doesn't make sense to include, but I'll include that too. For example, the zip code, I don't know if you would expect to see much of a correlation there. Latitude and longitude could be interesting. It could be that if you're on the north side of town or something, your house is worth more, but we'll just leave all of that in. And they've got a different variation over here of square feet and square feet of the lot, and I don't even know what those mean. They're very similar to what you have for the square foot of living space and so forth. But anyway, so first of all, I'm going to have to give it an input range. So I'm going to input all of the columns, and some of these columns have numbers that are continuous. Some of them have numbers like price. It can go from any fraction or whatever. Some of the numbers are discrete, like number of bedrooms. Some of the numbers actually only have 0, 1 values, like whether or not the house has a view. Well, actually it doesn't. It's got different numbers, so I guess that's the quality of the view. And then waterfront, in this particular data set, none of the houses are on the waterfront. The house is not, the zip code is not on the water. So all of those are 0, and that's going to cause a little bit of a problem when we compute correlations, but I'll leave that in there so you can see what happens. I'm going to click labels in the first row, which means I included the headers. And you always want to do that, because then when you get the correlation matrix, it'll tell you what each variable means rather than just have them column 1, column 2, and so forth, and then you have to figure out what they mean. This is going to be a big matrix of numbers, so we want to create a new worksheet. And so it looks like we're all ready to go. Let's press OK. And here's our correlation matrix. This thing is kind of a chore to read because the way the data is arranged. The first column there is price. So if I read down that column, it gives me the correlation coefficient between price and bedrooms, price and bathrooms, price and square feet living, price and square feet lot, and so forth. Number of floors in the house. And you remember that waterfront variable? It didn't work out too well because all the numbers were 0. So you just got a divide check in that, which is okay. It's not going to hurt anything. View is positively correlated with the price. The condition has a negative correlation. I would assume that's the condition of the house with price. Grade is probably whether or not the house is on a flat lot or a steep lot. I don't know. Square feet upstairs, square feet basement, year built. There's a positive correlation with the year built, which means houses built later, newer houses are worth more. year renovated, there's a negative correlation a little bit. I don't know that some of the houses, most of the houses don't have anything at all in that, but if a house has been renovated recently, there will be a date in that column. You could probably compute a variable a year since renovation or something like that, that would make more sense, and if the house had never been renovated, you'd just let that value take on the year the house was built. There is a positive correlation with latitude, and there's a negative correlation with longitude. Not very large, but it's there. And the square foot living, you notice that is less highly correlated than this square feet up here. So whatever adjustment they make in the living space didn't improve the correlation. In square feet of the lot, there's another variation of that, and that has a lower correlation than the raw square feet. And I'll need to check and later maybe be able to tell you what those two variables mean. So if you look down that column, you see the single the highest correlation is square feet of living space with price. And so that if you square that, you can find what percent of the variation in price is explained by square foot living. Now, if you want to look at some of these other variables as to how they're correlated, you have to read down and across the matrix, because bedrooms, if you want to know how highly the number of bathrooms is correlated with the number of bedrooms, you look down that column. But if you need to know the price, you have to go back over to the price column and go down to bedrooms. So it takes a little bit of hunting to find the correlation that you were looking for. For example, if you wanted to find the correlation between let's say the number of floors you have and the price, you would look at that in the price column. But on the other hand, if you wanted to look at the number of floors you have versus square foot of living space, you'd have to go over to the square foot of living space column. And if you wanted to know the number of floors versus the latitude, then you would have to go over to the floors column and go down and look at latitude. So anyway, that's your correlation matrix, and you could compute another matrix right below that in which you square all of those values. Actually, the correlation coefficient squared gives you a better estimate of the strength of the relationship. So you could do a little bit of Excel coding there and compute a correlation matrix squared, or correlation coefficient squared matrix. And so that's all for correlation coefficients. Later we're going to do some more stuff with this, but for right now this will suffice.